Looks like your cameraman today.
Okay.
Thanks, bud. Good morning.
Morning.
Good morning. How was your break? Short. Oh, short, sick. Did anybody have a good break other than me? All right, a couple people. Someday you will, I promise. Welcome back. We are officially halfway done with the semester. This is the midpoint. You're going to notice that things are changing a lot in terms of what the assignments in this course look like for the second half of the semester. We're now very highly focused on your project. So we've laid the groundwork with the core skills here, the 10 topics. We've played with them in JavaScript. We've played with them in Python. And as of today, you've now demonstrated your mastery of these things in the core skills demo. For those of you playing the home game, that means that 40% there plus another 10 or so is done from the the code sprints. And so about half your grade is done, and we're about halfway through the class. So got a pretty good measurement of how you're doing. If you're not done with these things, there should now be an exclamation mark in your head to hurry up and get it done. We remain here to support you. However, this is where we're at now. We're moved on to the individual paths to learn how to actually write the functions and the code in the language and in the environment for your project. And so that's where we're at now. If that doesn't describe you, you should know that you are behind. But we are still here to help you catch up. What day do grades start getting hurt? What's that? March 23rd, that Friday. Things start feeling really badly then, so let's not get there. Where can you go to get help? The engineering library. When? Anytime it's open. Where else can you go to get help? Online. What's that? Coding help at temple.edu. Responded to several times daily. Where else could you go for help? All the social media pages at ENGR1102 on Twitter, Instagram, Snapchat, YouTube, LinkedIn. It's all there. Plug in, help me, help you. However, you should also know every assignment needs to be done with a 70. You get as many tries as it takes to get this to happen, but you got to do it. So get there. So, recap here. This week you should be done with JavaScript, Python, core skills. We are moving on to the IDE GUI for your project. That's going to be due a week from today. And I'm going to be talking about the following topics this week, all things that are going to be very helpful for you in your future engineering career. This code sprint's going to be a fun one based on what we do in class today and on Wednesday. Lots of tips and tricks on how Friday's code sprint works for you there. But I was thinking about something before we get into that. Now that we're halfway through, let's reflect for a minute on what it's like to be a student. I think that college is one of these things that really demands you to manage your time well, but I don't think we're really spending a whole lot of time showing you how to do it. So I thought I might show you the way that I manage my time. And I did this as a student as well, and it made life a lot better. It helped me when I was in school mode maximize my learning and get my work done, and it helped me when I was out of that mode to maximize my fun and the other things that I do with my life. I think that you have a lot on your plate. You don't need me to tell you that. The average student takes 15 credits. The average student at here, since I've started polling, actually has 16-hour job, punching a clock somewhere to make money and pay the bills. In addition to that, you're signed up for organizations, activities, all these kinds of things, trying to boost that resume, trying to be involved, engaged in things that are fun. Oh, at some point we're supposed to get some rest. And while we're at it, we're trying to make friends, find the love of our lives, and all these other things. So here's how I handle it. There are exactly 168 hours every week. That's what you get when you multiply 7 by 24. And so my strategy is that I start by managing my commitments, and then I decide how much time I'm going to give each one of them. So for example, did you know that the university, the reason they let you sign up for the number of credits that they do, they're doing the math that they expect you're spending 3 hours per credit per week outside of class? That's what you should be doing on your homework and your studies and your book reading and all this kind of stuff. So in addition to that, you've got 15 hours in lecture. We multiply that by 3. That's 45 hours of homework and study. So when we say full-time student, that's because it takes more than a full-time job to do it. What's 15 plus 45? 60 hours. If you work 60 hours a week, 5 years after graduation, you should think carefully about your life. In addition to that, theoretically, you have a 16-hour job. So now that puts you at 76 hours a week. We would like to sleep 7 hours a day is a healthy amount. Everybody smirks at that one. 49 hours. How many hours of free time do you think we have left? Interestingly enough, it's not 0. It's 43. You have a full-time job still left over if you do these things. 6 hours of free time to eat, sleep, commute, hang out with your friends, binge watch some TV, be involved in organizations. all those other things. And so the question I have is, how many of you think you're actually spending 45 hours a week on homework and studying and things like that? Handful. Imagine how easy college would be if you actually managed your time and got to a point where you were doing that. Learning takes actual time. So, here's how I do it. I actually make a little schedule for myself, but what I do is I schedule blocks of time for things like homework or nowadays prepping for lectures and whatnot. So here's what I've done. I started with the things that I don't get to move around. I have to be in a certain place at these times. By the way, this is a semester schedule from a time when I was in school and working 16 hours a week. Next, I fill in my study time. It looks like that. That's 45 hours of study time. Oh, by the way, while still getting 7 hours of sleep a night, I left myself an hour break here for lunch, 2 hours at dinner time, most of Saturday, sleep in on Saturday and Sunday. Oh, and by the way, these are kind of the catch-all time where if I didn't get it done during the week, I've got some backup, but oftentimes I didn't have to do anything on Saturday or Sunday because I actually protected this time and did my job as a student. Then we had 16 hours of work week. Yes, I really did that too. I waited tables. And what you have left, all this white space, is time that you get to decide whatever the heck you want to do with it. That's 7 hours of sleep. You go to bed at midnight, wake up at 7 a.m. I know the font's small. Give yourself an hour in the morning, an hour at lunch, couple hours around dinner time, some time in the evening to unwind and have fun. Join organizations, whatever it is you like to do. This is how I actually do it. Once a week, every Monday, I sit down and I make a new one of these because, for example, today I have a meeting from 12 to 1 that I don't normally have. And so I punch that in, and now I've got to find what I would have done there, another block of time to do it. What happens when you do this is then you can sit down and say, okay, it is 3 o'clock on a Monday. I'm supposed to spend the next hour working on homework. And then I sit down and I work for 1 hour on homework, and then I stop, whether it's done or not. Got to go to class. I take my break, and then I sit down and I spend. And what happens is, by commanding the amount of time you're going to spend on something, you never say the following sentence anymore. Well, that took longer than I thought. Because at 10 o'clock, you know what I do? I close my laptop and I go have fun. And strangely enough, after a week or two of this, everything seems to get done. Is it easy? No, because it takes a little bit of discipline to actually stop and start working when you're supposed to. However, I have found myself enjoying my free time more since doing this because when I'm at work, I'm in work mode, and when I'm not at work, I'm completely not in work mode, knowing that everything's handled. It's no longer this crazy scramble to try and figure out how to get it all done. So, I encourage you to give that a try. If you'd like help implementing that, feel free to reach out to me. All right, now, computer programming. Yeah, question? Yeah, that was just Excel. You can use like a calendar app or something like that. I just get irritated with them, and so I just do a spreadsheet. And I had to merge some cells and things like that. But yeah, it's just Excel. And you could be more specific, right? If I've got 3 hours per credit per week, that means I need 9 hours for this class, for example. I actually label these blocks with the class that I'm going to work on. This weird thing happens too, by the way. Sometimes you'll realize that you don't have anything you have to do for that class, but you still have time left in your block to work on it. That's where I got creative and started reading extra, finding a little bit of, an extra article or read the textbook where I wouldn't have normally read the textbook, things like that. And those were the little 15-minute interludes in my life that I think really solidified my learning, and this is when I kind of turned the corner and started doing well in school. Things like this are what took me from actually failing classes and chasing after solution manuals and trying to find friends to help me with everything to being able to just get it done myself. Cool question. Any others? Yeah. I'm sorry? In making this schedule, the first time, not going to lie, it took me like an hour and a half, 2 hours to, like once a semester, it takes about that time to move all the pieces around, get it lined up and working right. If you saw my actual one for this week, it's pretty complicated because I've got so many different meetings and things. But once it's set week to week, the edit, 15 minutes. Every Monday morning, I sit down, 15 minutes, get my week together, and I'm good to go. So yeah, a little investment up front, but then I just always know what I'm doing. And this is just always open on my laptop, and I always check it to find out what I should be doing next, and that way I don't have to waste any time thinking. We good? Learn some science? Okay, so what I want to talk about today is simulating or calculating equations on a grid. We've all seen equations like this before from algebra class, right? Y of x is x squared plus 3. How would I evaluate that? If I wanted a value for y, what would I do? Yeah. Plug in a value for x. For example, maybe I want to use x is equal to 3. And so I would take a 3 and plug it in. So now I got 3 squared plus 3 is 12. So my value for y is 3. Do I have to use 3? No. I could use 8. I would plug 8 in and square it and add 3 and get 67. Or I could use 14 and do it. And as you could imagine, I could keep plugging in whatever number I want, and for any value of x, I can get a value of y. What if I wanted to make a graph of this equation? How would you make a graph of this equation? I give you an equation, and I say I want a graph. Yeah? I'm sorry? Okay, so evaluate it for a whole bunch of x's, plot all the points, maybe play connect the dots or something like that if I wanted to. Yeah. A convenient way to keep track of all of that might be to stick them in a table, right? I could have values of x's, values of y's, something like that. And if I used enough unique values of x, I would get enough unique values of y to be able to make a graph of this thing and see it do something. So let's go over to Excel for a minute and play with this and see what we get. So I've created a file here. This will be uploaded for you guys. And tell me in the back when you can read this. Nope, that's not how to do it. View. Back row? Cool. All right, so just looking here for a minute, what I wanted to do was, animations. I want a column for x, and I want a column for y. So I'm going to do x here, and just to remind us, y of x was equal to x squared plus 3. So for example, I had a value of 3 there, and in Excel, if we want to do an equation, you just hit the equal sign and then type the equation. But you can click on the variable you want. So for example, I want to take that value and I want to square it. And then I want to add 3. And I hit enter and I get 12. And I think I had one that was 8 before. And I could either type that equation in again, or Excel's got this handy little thing down here in this bottom right corner. You see how my cursor changed to a plus sign? A black plus sign, not a white one. If you click that and drag, it just moves the cell down one, moves the equation down one, and it auto increments. So if you look, the original equation was for cell A2. That's column A, row 2. When I drag it down, it added one to the row. And so you'll see here, this is still column A, but now it's row 3. So you can drag them down and it'll keep evaluating these. Okay, so that's kind of nice. But if I want to make a graph of this, we want to run it for a bunch of values. I don't want to type them all in. Maybe we'll start at 0 and we'll go by ones for a while. So we can type 0 and 1 here. And if I highlight both of them, so now it sees a pattern of incrementing by 1, I can grab this little down the corner again and drag it, and you can see it's telling you in the little tooltip here what value it's putting in that cell. So like here's 1 through 10. And if I keep dragging, it'll just keep going, and I could say go to, I don't know, 20. And then I can take this, and interestingly enough, once you have one column filled, all you have to do is double-click that little box, and it'll fill the other column to the same number of rows. So if I double-click here, it stopped where it ran into something, and then if I double-click it again, it automatically filled the whole way down. And so now what I have are a bunch of values of x and a bunch of values of y. And so like in Excel, I can go in here and I can add a chart. There's all kinds of things. Here's a scatter plot. So I could click that. And if we select the data, tell it the x values are here. And we just want to highlight all of them. So you click one cell and hold shift and click the other, and it selects the whole range. Hit enter. And the y values here, click these and hit enter again. And we hit OK. And it gives us nothing, much to my embarrassment. So let's try this again. What did I do wrong? Maybe I need to add a series here. How about that? X values, Y values, boom. We could call it something cool like y equals x squared plus 3. And we have these dots, and you can see a trend line here. This is just what you were telling me to do. Of course, I could change the chart type and actually connect these dots if I wanted. Somewhere in here there's a button for that. Not going to bore you with it today. And so what we've arrived at is kind of an interesting thing. We can think in terms of continuous functions, but computers can't. Computers just think in terms of values. There is a value of x, and along with it, there's a value of y that happens if you do something to that value of x. And if I build enough of these, I can get a nice graph that looks like this, and lo and behold, it looks something like a parabola. We call this our x grid. It's the values that we are looking at our function on. What if I wanted a more precise graph? What would I do? How could I make this more precise? Yeah? Change the increments of x. Change the increments of x. So for example, I could make it go by 0.1. And if we drag this down, you'll see now that 20 points only gets us to a value of 2. But there's no reason I can't just keep going hundreds and hundreds of points down here. Up, now we go all the way to 26. And if I come back here and just double click this, it'll fill it all the way down. Now my graph doesn't look that much different. How come? Yeah. Right, so my data is still just looking at the first 20 points here. See, x ends there. So I have to go in and kind of update that, make it a little smarter. So let's come down here real quick and bang. And of course that means we need to fix this one too. We can click here again and come the whole way down. Man, that's a lot of data. Bang. Now I haven't changed the window on my graph at all, but what you'll see is it almost looks like a straight line now because there's so many points that they're overlapping each other. And so we can kind of get a really, really crisp picture of this now. And so what we did was we refined our grid x, which gives us more values of y and gives us more detail about what this function is doing. So we got ourselves a graph that looked like this. I used a different plot here. The only difference is to make this picture, I used one of the connected the dot graphs. And so Excel drew a nice line connecting all those dots. And once again, what we started with was an X grid, a bunch of values that go from 0 to 20. And we took each of those values one at a time, and we stuck it into the equation, and that gave us a new value of y. And we added that to our table, and away we went. So we see the process here. First I want to take 0, square it, and add 3. Store that as a value of y. Then I want to take 1, square it, add 3, store that as a value of y, and so on and so forth, right down this list of all these different x values. So instead of looking at just one value, we want to look at a bunch. Any theories on how we would do this, not in Excel, but maybe in Python? If I wanted to evaluate one item at a time, yeah. Arrays, okay, so that's definitely going to be part of it, right? We're going to want to create an X array and probably an array for Y to catch all of those values. And then how do I go through the values in X, do the math, and stick them in Y? Yeah. A loop. Cool. I think I heard it over here too. So let's do that. Trying to remember the font size that worked here. 25. Is that readable? Have we done this to ourselves again? Back row, we good? I see heads going up and down. Okay, I'm going to assume that means yes. So we want to create a grid of x's. How could I type in an array? If I just wanted to tell it the numbers that go in there, what would I do? Say I wanted to put 1 through 5 in there. Grades on the homework assignments indicate to me that most of us know how to answer this question. What's up? Brackets, right? And if I want to type a bunch of values in, I could do something like this. So there's all my x's. But I want to get a little fancier than this. I want to be able to start at any value of x, stop at any value of x with as many points as I want to put in there. And so this is where it gets a little different. Remember, here we go. Remember when we were in Excel, we basically picked an increment, and then we had to add those values one by one by dragging this little box down. And that created our initial X array. In Python, we can do a little trick. If I wanted to fill an array with zeros, I can write that in one line that looks like this. Except I need a value for nx, so how about we'll start with this being like 10. What's this going to do? I'll give you a hint. It's the same as this. Yeah. X equals 0 from 0 to 10. So what's x going to look like if I were to do print x? What's x going to look like? Huh? It's going to go from 0 to 10? All right. So we save this and we run it. Once again, I'm just using a really simple editor called idle. It will pop up a second window here and it'll run it up. Look at that. We got zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. We got 10 zeros. So this is kind of the shortcut for creating an empty array. This is the Excel equivalent of saying we're going to have 10 boxes. But what if I wanted to stick something different? What if I wanted it to be from 1 to 10 like you said? What would I change? So instead of putting a 0 in each box, what do I want to put in each box? I'm sorry? A new variable. What's the value of that variable the first time through the loop? If I want to count from 0 to 10, the first time through I want to stick in a 0. The second time through I want to stick in a 1. How about the third time through? A 2. Is there already a variable in my world that happens to be taking those numbers? I heard it. I. So instead of putting a 0 in there, if I put an I in here, once again, that's the same as saying that. Same code. Now I'm going to get what you wanted. I'm going to get, the first time through we did it with zeros, so we got zeros. The second time through I did it with I, so I got I. And it goes from 0 to 9. All right, well, while we're at it, how would I now calculate y? Following my same code. Yeah. Y equals and then do the same thing? I for I in range 10. Something like that. What's that going to give me for y? It's just going to give me the same thing, right? But I want to use this equation. I want to use y equals x squared plus 3. So there's 2 steps to getting this to happen. The first step is I need to create a variable called y. And the second step is I need to evaluate all those x's and stick the answers in there. Yeah? Ooh, okay, so use x of I squared. Something like that. Right? Okay, so how about we start with what we call initializing y. By just filling it with zeros. And then we'll evaluate on a separate thing. So if I run this right now, I should get, yep, there it is. So this is x, this is y. I just started out with it filled with zeros. And now I can use a for loop, like for I in range 10. And I can say y of I is equal to x of I raised to the second power plus 3. And when we're done with that, we can print y. And if I did my job right, and so what I've done is I've gone through the X array item by item and stuck the answer item by item into Y, one at a time. If you don't believe me, watch what happens if I put the Y in here. What do you think is going to happen now? How many times is it going to print Y? Huh? 10 times. Boom. So the first time through, it stuck the 3 in. All the rest of the elements were left alone. The second time through, it stuck the 4 in. The third time through, the 7, and the 12, and the 19. So you can see here, it's just filling this in one element at a time, just like that. What if I wanted to use values of x other than 0 to 10? I'm sorry? Change the range. Okay. So change the range to what? All right, let's say I wanted to go 0 to 20. Like that? Do I want 20 spots or do I want 20 to be the highest value of x? I want 20 to be the highest value of x. So I have to go to 21. For those of you who didn't catch that, range always ends 1 early. And so if I run this, it stopped at 19. And so I have to go to 21. Only something's happened. How come I stopped? I only did the first 10 elements down here. It still has a 10, right? Okay, so I got to come down here and type 21. Oh, now I got to come down here and type 21. And save it and run it. Okay, so now it worked. All right, now I'd like to go in increments of 0.1. What do I need to do? Oh, I just made it harder, right? So you may recall, right before break, we played with this fence post problem. Do you remember where we took x max minus x min, we divided it by nx, and it gave us the wrong increment? And we discovered the classic fence post problem, which is you actually want your delta x to be nx minus 1. So it's always 1 less than that, right? And this is easily remembered by tearing up a piece of paper. If I want 2 pieces of paper, how many times do I need to tear the piece of paper? Huh? Once. If I want 4 pieces of paper, how many times do I need to tear the paper? 2 more times for a grand total of how many tears? 3 tears. So it's always 1 less cut than there are parts that you want. Fence post problem. And so we can define any grid we like. Let me just get myself a little room here. I'm just putting some blank space in. I could define something like x min. Maybe we'll make it 0. Maybe we'll make x max equal to 20. So far nothing's changed. And now I tell it how many grid points I want there. So let's start with trying to get it to do exactly what it was doing before, and then we can mess with it to see if we've made it even better. So we're going to have 20 values of x, and that means that we need our dx to be what? Well, right here. X max minus x min over nx minus 1. X max minus x min divided by nx minus 1. And then we can go borrow this. And instead of range of 21, we need that to be 21, right? Nx here can replace that variable. And now if I change it, my loop doesn't have to change size, which is super convenient. So if I run this, we've got some crap that's going to print from above, but the last thing that prints is x, and it went from 0 to 20, just like we hoped it would. All right, so I'm going to change nx now. Instead of it being 21, I want to make it 101 points. and I run this, we have a problem. I still want it to go from 0 to 20. I want it to take 101 steps to get there, and instead it's gone from 0 to 100 in steps of 1. What part of my code needs changed now? Okay, so my range is wrong. What's my range need to be? Sorry? Needs to be the X max. See some hands here. Yeah. I'm sorry? DX needs to show up somewhere, that's for darn sure. Yep. An if statement? What would that do? If it's less than max, run. Okay, so I see we want to stop at the right spot. Yep. Aha, right? This I here is part of our problem. That I, no matter what's going through, it's just grabbing the values out of this range function, which is filled with a bunch of integers. So let's smash all of that together. First, we'll do it here. Remember, on this grid, we wanted to go from -2 to 1, and we wanted to do it in 11 steps. That gave us a delta of 0.3. And so the first step, we start at -2. We add a delta. Then we add another delta. Then we add another delta. So how many deltas have I added to get this -2? Our starting value. Give you a hint. It's written right above it. 0. How many deltas have I added to the -2 to get it to go to 1.7? Give you a hint. It's right above it. 1. How many deltas have I added to get to -0.5? 5. So if this were in a loop, how many deltas am I using each iteration? Huh? I can almost hear you. Just I, right? This row right here is I, counting the number of times we've gone through our loop. And all we have to do is start at the x min and add delta x's, and eventually we end up at x max. So let's try that. Okay, so we're going to do it nx times again. Let's go back to that. But instead, what I want to do is I want to start at x min, and I want to use I dx's to get there. And now if I run this, I will have taken that. Oh, okay, that's too hard to look at. Let's do the same grid that we did in here. -2 to 1. So I can do -2 to 1. And we used 11 points. And I can run this module. And I should get, there we go, 11 points that go from -2 to 1. So let's think about this code for half a minute. What it did was it starts at x min, and every time we go through the loop, I increases by 1, right? The original thing we did right here shows I going from 0 to 20. So it's basically one time per iteration, I gets bigger. And then we take that and we multiply it by our delta x to decide how many delta x's we add to x min. So we take 0 delta x's the first time through. We take 1 delta x the second time through. We take 3 delta x's the fourth time through, and so on. We just keep adding 1 more delta x every time. And now we've filled in our x grid to go from -2 to 1. And here's the neat thing. I can go, whoop, where's my mouse? There we go. I can go back here and grab my y evaluation. And what needs to change for this to work? There's only one thing, but what is it? What do I need to fix to make this run? The range? What's it need to be now instead? I heard it. NX. NX. Look at that. So, negative 2 squared is, let's check this. Negative 2 squared is what? Huh? 4 plus 3 is 7. All right, let's do another easy one. 1 squared is, in unison, 1. Okay, plus 3 is 4. And so on and so forth. 4. What happened over here? Yeah. Oh, look at that. It only did the first 11 values. Farther up in my code, I filled it with 20 values. So this stuff down here is just leftover crap from earlier in my code. How could I fix that? Yeah. Redefine the array. I can't hear you, what? Oh, like use a different variable name? Okay, that's great, except it fills up my memory with garbage. But we could do that, right? We could just make this, I think you said Z. That should fix it. This is certainly a solution, right? Except Z is not defined. Because, right, we need to create it somewhere first, right? So we want something like this to initialize it again. So we can initialize Z for a range NX. And now it should work. There we go. Okay, so that's a solution. What's another way we could have fixed it? What's that? Okay, just print the first 10 values. That is a classic memory leak because now there's still that extra data stored in memory and eventually our computer is going to want that back. Just because we don't look at it doesn't mean it's not there. Details. We want to clear it out and start over. How do we clear out an array and start over with a new one? Huh? Set it to 0? We should be able to just reinitialize it. Let's see if this works. If we just reinitialize it using this line here, it should just overwrite y with a new thing that only has the number of elements in it that we want. That works in Python. It doesn't work in every language. In other languages, you have to initialize things a little differently, right? If I were in JavaScript right now, what word would show up on the page? Huh? I heard it. If I were in JavaScript right now, what word would I have to add to get myself a fresh array? Ooh. Looks like we've got homework. You can answer that one on Wednesday. Any questions? So, when is everything that I've mentioned in this class due? People who like to get good grades. The rest of you are dismissed, but if you like good grades, stick around for one more minute and answer the following question. When is everything that I've mentioned so far due? That's a trick question. The answer is tonight. But it'll start hurting on March 23rd. But there's new stuff to do. So, get her done. Have a good one.